There it is. By golly, ladies and gentlemen, stargazers, armchair astrophysicists, members of the Santa Barbara Astronomical Unit. Welcome to the SBAU Astro Hour. I'm your host, Ron Heron. We are the South Central Coast Longtime Telescope and Astrophysics Club. And doggone if Alex Filippenko didn't have his start here back in 70. I learn a lot from my very knowledgeable comrades I'm about to introduce to you right here at SBAU as Vice President. And I'll introduce you to the Brain Trust in a moment. You can watch us on YouTube. We're on there right now, streaming live on this Monday, the, 18th of March through the 24th, which is next Sunday. This is episode, you ready for this? Number 161. We've been getting together, the 4 or 5 or 6 of us on screen for over 3 years. We're in year number 4. Here's what we're going to talk about tonight or today in the Astro Hour as we try to get our 6th member on the screen. Doggone, you're not going to believe, gang, what's going on out at Betelgeuse, that red giant. My God, I've never seen a star like that before. Wait till you see the moving images. It's an ecliptic tilt. And I'm not talking about our date with destiny, April 8th, 3 weeks from today, with the sun or 45% of it being eclipsed. But even your best friend will tell you if you have an ecliptic tilt. Out at Jupiter's Galilean, apparently the moons ain't lining up with the plane or the orbits or something. We'll get into it. Comet Pons Brooks is very bright. It's falling into the sun. Can we see it soon? Perhaps. Venus and Saturn are getting close together. We'll get a report from one of our guys here in a minute. Mercury approaching maximum elongation. Got some new look inside Mars with the interior of our nearest planet outward is a little different than we thought. And it's vernal equinox tomorrow, everybody. Spring has sprung. So let's meet the gang. These are the Brain Trust, our beloved president and in control, Jerry Wilson.
Good morning.
Captain Kirk of the Starship. Thank you, Jerry. He's married to Pat Forgy and has been our leader, and as far as I'm concerned, a professor of astronomy here on this course I take every Monday morning for about 5 or 6 years now. Chuck McPartland, our outreach coordinator, is one of the best on the planet. He's married to Pat McPartland, our merchandise manager and new treasurer. And Chuck is going to, as far as I'm concerned, he's the heart and the soul of the club. In order of joining us, Tim Crawford, who's married to Karen, resident lens and telescope expert, will contribute a lot. We have, ladies and gentlemen, Tom Whittemore, editor of our beloved newspaper, our newsletter every month, which every member gets online. He's married to Maureen, former science instructor out at Westmont. And Bruce Murdoch's name is on the screen. I'm not sure. Can we hear you, Bruce?
No, his audio is still flickering.
Well, we have his name, unless that's a post-mortem and that's an in memoriam. And did we lose Bruce over the weekend?
No, he'll connect. It just
it's not going to post his birth date, 1938. True. It's funny. Never mind. Gentlemen, let's do the silly cartoons because I got my version. I've done my transcriptions, and Jerry forwards these to us. Science-based cartoons. Now this is the one. Is this the one with the? Okay, that's does look like a Far Side from Jerry Larson, but you're gonna have to explain it. What's going on here, Jerry?
This is the mathematical version of the 90-pound weakling being outclassed on the beach by a big muscle-bound guy.
Okay,
this guy is displaying a lot more math than this guy.
But those formulas don't mean anything to you. Is that just gibberish?
No, they do, but they're simple little things. Okay. But these girls are loving him.
Got it. He could have been guy on the left could have been a little skinnier, but that's all right. Guy on the right. No, wait a minute. Did I get this right? The hunk is sitting next to the women, and
no.
Oh, it's the other way around.
Yeah.
Oh,
the math replaces the Hulk.
All right, we got a lot of this math in your cartoons this week. Let's see if another one comes up here in a minute. These are the scientists inside the lab checking out the sad rubbery remains of somebody on the table. The director of the lab says to the gentleman, "My God, it is Professor Dickel. Weinberg, see if you can make out what the devil he was working on, and the rest of us, well, you get back to your stations." Now, you want to tell us what happened to him? Or
don't know. looks like he sort of dissolved his bones.
Yeah.
Oh, God.
I would be running screaming from the lab, but that's
Okay. Typical Far Side, I got to tell you.
yeah.
All right, this one I don't remember getting. Falcons can live to be 12 to 15 years old. Oh, yes, I do. All falcons, thus alive today, were born in the 21st century. These happen to be millennial falcons. Okay, you're right.
For you Star Wars fans.
Your Star Wars, yeah, we know what the millennial falcon is. Two men in New Zealand. Here's what I wrote about that. The Earth sandwich. A couple of guys in the photos, one in New Zealand and in Spain on the other side of the Earth, created the Earth sandwich by placing bread on precise points of the Earth, either side of the planet at the same time. Now, if one of them had put lettuce and tomato under his bread and the other put bacon, they'd have not a BLT, but a BBLT, a big bacon and lettuce tomato sandwich. I suppose this was done. Why not?
This is what happens when you know science and you've got way too much time on your hands.
I suppose so. I always heard China was on the opposite side of us, but I don't know if that's true or
No,
not.
that's just a phrase.
It's
right.
Northern Hemisphere, and so are we, so it can't
Yeah.
be.
That's true. You're right. Here's the Pi Day cooking instructions. We had Pi Day last 3/14. Was last week, Thursday, I think. Based on Egyptian hieroglyphics on the wall of an ancient tomb for baking, just as Tom Whittemore and his wife do all the time, along with sourdough bread. 2 pies. Bake 2 pies in the sun for 90 minutes, and what the hell do you get?
In a circle.
Handful of pie.
A bunch of dinosaurs gathered at the symposium listening to their reptilian version of Neil deGrasse Tyson, I guess. Yeah, the picture pretty bleak, gentlemen. World's climates, he says, are changing and the mammals are taking over, and we all have a brain about the size of a walnut, so that's going to be a problem. He also added, I think there's an asteroid in the neighborhood.
Yeah.
Speaking of astronauts, they use Linux. I remember writing this because you can't open Windows in space. What is Linux? I'm sorry, I missed that one.
Linux. It's an operating system.
Oh, it is?
Yeah.
I thought it was a cleaner that you bought at CVS or something. Linux.
No, it's an operating system competing with Windows.
So
it gives you more access to all the detailed tuning and technical things.
So it's a software, or might you even call it an algorithm? I just learned the definition of algorithm.
No.
It's
It's a freeware it's sort of a freeware version initially of Unix. So that's why it kind of has that name.
All right. These are funny stuff. It's great. Oh, and then we're back to Lars, the 2 men on the beach. I love this. Okay, we got lots to talk about, and I got lots to learn. It's taking a slow time because I'm getting old. Bruce Murdoch, where are you? We want to introduce you. Not sure what's going on with him and his sound on one.
Oh, he may be there now.
Bruce, can we hear you? There's an unmute at the bottom. Where are we go? Oh, is this? Oh, we're going to go out to Red Giant. I mean, a red giant. We'd be in the middle of this if Betelgeuse were in our solar system, wouldn't we?
Oh, yeah.
Which means.
But what's going on here is about a couple months ago, we reported on a paper published in the Astrophysical Journal that gave observational data on the star Betelgeuse that made it look like it was rotating very rapidly. And that surprised everybody because really big stars, and Betelgeuse is a very big star, they generally don't rotate very fast. As something gets bigger, it slows down. It's the opposite effect of the ice skater bringing her arms in and speeding up. So the speed that the Betelgeuse was supposed to be rotating at was very startling. So a group of people at the Max Planck Institute for Astrophysics proposed a different interpretation of the same data. And what they did was they simulated Betelgeuse based on fundamental physics of heat convection in some body like this. And then they did a simulation. And then they blurred the simulation to what it would look like for the ALMA radio telescope array in Chile, if that were looking at it, because it doesn't have the resolution that the simulation had. And they pretty much reproduced the data that they saw, but with a very different interpretation of where it comes from. And as you'll see in a minute, this is a picture, a frame from the simulation showing basically convection cells of Betelgeuse with things rising and sinking. This is, for example, a frame of Doppler shift from the array or from the simulation. Blue is coming toward us, red is going away. So these cells are coming and going back and forth. And they can give, they're basically convection cells. And they covered several cases of things like rapid rotation, large convection cells, and small convection cells moving coherently.
We could call them big bubbles, couldn't we?
Big bubbles is good, yeah, yeah. Now let's see here.
Wow, look at that.
I got to get to a
Never seen a star like this. Ah, there's the monoliths.
Yeah, the monoliths will be there for a minute.
Okay. I need those also Zarathustra
Yeah.
medley, right? Dun dun.
Or the Barbie movie intro.
Oh my God, that one I haven't heard yet. God help me.
Okay.
Okay, we've been blocked. Are you trying to go to the video?
Yeah.
Yeah.
Oh, good, good. I was hoping we could see that. Now I think Bruce is joining us, ladies and gentlemen, while we're setting that up.
Bruce Murdoch, yeah.
Perhaps will talk to us if we can't see him.
He's not
You're
showing
muted,
on my
Bruce.
screen.
He is we do have a member that has more time spent with us than he does the group called the Theater Organ Society that he's president of, but that's all right. They're not quite as
There
active.
he is.
Can you hear me?
I hear you only just as well. We don't get to see your ugly mug. Sorry, Bruce.
Well, let's see. Somewhere down the bottom here, I can turn video on.
We're going to take up a collection and buy you a little Dell laptop for $400.
There you go.
All right.
That's just another piece of equipment that's going to clutter my desk.
Well, no, you'll just throw out these things that don't work. Awesome. Okay, get ready. You're just in time, Bruce, to join us in the middle of Betelgeuse.
Can you see this okay?
Oh, yeah.
Sort of.
Coming
Yeah.
right at us. God. That's
So this is the animation that shows the simulation of the bubbling of what Betelgeuse is believed to look like in this simulation. This shows the size of Betelgeuse. This thing around here is the orbit of Jupiter. So it's a very big star.
Wow.
And now they're looking at Doppler shift, the rising and falling. Blue is coming toward us. Red is going away from us. Remember, this is simulation, not images.
And it certainly doesn't go that fast.
I don't know.
In real time. I mean,
yeah,
couldn't.
And now they're going to blur it as what you'd see with the ALMA array.
Yeah, there you go.
And it can give you the impression that it's a rotating body.
Oh.
Because this is what the ALMA would see. And it corresponds very closely with that.
Yeah, it really does.
It's not turning, it's just convulsing.
Well, probably a combination of both, but
yeah,
mostly convulsing.
Well, the fact is, something turning, a surface turning at the orbit of Jupiter could go just as fast, but you wouldn't see it very fast.
And this is the Doppler shift blurred.
Takes how many years for Jupiter to get around the sun? 12?
12.
Okay, well.
Okay.
Amazing. And they still think it's going to blow any day?
Yeah, still.
It may have already blown.
Yeah.
Well, that's true.
And it's dimming again. It's down a couple of points in magnitude, a couple of tenths, I think.
But it's not a Cepheid?
No, it's not.
Oh, no.
So, but it does dim and then brighten over time.
Yeah, a variable star doesn't have to be a Cepheid.
Variable just takes its whenever it wants to, but a Cepheid is on a regular scale or time. Got it. Time frame.
Very precise clock.
Okay, now we're moving on to, now that we've resolved the issue with Betelgeuse, which is not rotating very rapidly. We move to the fact that I think last night or tonight, I think this will happen for us on the West Coast during the day. But the idea is the same, and that is, you see, this is a picture of Jupiter from a planetarium software, and you can see the moon Callisto is above Jupiter, where it would have gone behind Jupiter if we were lined up with the plane of Jupiter's moons. They are all rotating around Jupiter in a single plane, but that plane is tilted very heavily toward us, looking down on it. So right now it does not correspond with the ecliptic.
Well, Callisto is tilted more than the other moons, and that's why it can go above or below.
Right, because it's the moon that's the farthest away from Jupiter.
Yeah.
Is the rotational axis of Jupiter orthogonal to the plane of our solar system?
Sometimes.
So the same thing happens with Saturn, only it's the ring we see tilting, doesn't it?
Yes.
And it's tilted much more.
Yeah.
Is it really?
Yeah.
But all the planets are in the ecliptic, the plane of the solar system.
No,
right?
no.
Except for Pluto. I know Pluto.
No. I mean, there's a general plane, but there are a couple of degrees of variation depending on the planet.
Okay. So that's what this ecliptic tilt means. Doesn't mean they're out of the plane. They stay in the same plane. They just get tilted away from us.
Yes.
No, well,
the tilt issue.
Okay.
Well, there's both a tilt of the axis of the planet, and then there's a tilt of the plane of the orbit. So there's a couple of things going on.
You know what they should call it? The pinball effect.
Pinball. Yeah.
It's got tilt on the screen there. If you've ever
The
played
early solar system I've read was quite a pinball game.
Oh, I'll bet it
Many planets, collisions. Theia collided with the primitive proto-Earth.
Those were the flippers.
And then some of the Jupiter was supposed to have formed closer to the sun and moved out and stabilized everything.
Yeah, I
So
don't understand.
there's a lot of motion in the early things. Sort of to expect all the planets to be in lockstep in a single plane and all with their axis nicely pointed perpendicular is didn't happen.
Yeah, Ron, what was going on is there was not as much empty space as there is now. There was stuff, okay? And so these things experienced some viscosity as they were going around. You can think of it as friction. And so they moved in and out as they were tossing things away, especially Jupiter and Saturn were big. They formed far away, actually. Then they moved inward, and then they moved back outward again. And in the course of that, they threw stuff all over the place. And it was the interactions with the stuff they were throwing out that changed their orbits.
Bruce?
They also absorbed a lot of stuff, right? Collisions.
Yeah.
Oh, sure. I just don't understand how something that size moves in and then decides to move out. What the heck?
Because it's interacting with the medium it's moving through. There was a bunch of stuff that it was moving through. Like, I mean, not quite as bad as molasses, but it was affecting it.
Yeah, well, there was dust and gas. Through. Okay. We were in a big nebulae back then, right?
Yes, well, sort of. I mean, even after we blew a lot of the gas away, there was still stuff.
Got it. But it's stabilized now.
Yeah, the light dust got blown away. The heavier stuff, the chunkier stuff stayed.
Jerry, for a question for you in relation to the last topic about Betelgeuse rotating rapidly. Jupiter rotates about every 10 hours.
Yes.
Would that be considered to be too fast or
too fast?
Well,
no. We have a good measurement of it's not controversial about Jupiter. We have a good measurement that the surface that we see rotates in 10 hours. Whether that's one hell of a windstorm on a surface down there, but I don't believe Jupiter has a surface per se like the Earth does. So,
and it's noticeably squished. I mean, it looks sort of a little bit elliptical.
Right. If you look at it closely, it's not a circle. It's flatter at the poles and bulging at the equator.
But somebody on the Earth on the equator is going 1,000 miles an hour.
On Earth.
Somebody on Jupiter at the surface, let's say in a boat or a balloon, is probably going hundreds of thousands of miles.
I wouldn't go that far, but they certainly are going faster.
Yeah.
Yeah. Amazing. Will
Well, you
that
can
red
scale it fairly simply. Look at the diameter differences between the Earth and Jupiter and multiply it by our rotational period.
Yeah, scale with periods.
There you go. We're back to the moon. First quarter. Ready?
First quarter was yesterday.
Yeah,
Okay.
that's the moon I saw last night.
These are pictures from our SBAU website on Facebook, run by Ruben, one of our club members.
Mhm.
Nice pictures.
He does a great job.
Yes, he does.
That's not called a half moon. That's a quarter moon.
This is the first quarter. So we
Okay.
see 1/4 of the moon illuminated from noon to dawn.
But they
Or
don't
another
call
way,
the
it's a
full
quarter of a
moon
way
half
through its
moon.
phases.
They don't
Yes,
call the
that's-
full moon the half moon,
Hmm.
right?
It's what?
They don't call the full moon the half moon
No.
because you see
No.
half the moon in the full moon when it's in the full moon phase.
Yeah.
Yeah, that's kind of confusing to the regular layman out there, isn't it? Here's
Nah, never bothered me.
a
So the astronomy magazine points out a feature that's it's a little, the terminator we saw was right here. So this is a little, this square down here, which is this, showing Maurolycus, is a little more into the daylight than this picture was taken. But it's a very interesting crater structure, a larger crater, an older crater with other craters in it on the rim, close to it, messing up its rim. So it was a very early crater.
Hmm.
Now, one of the things you can see about this time is what was called the straight wall when I was a kid, and we looked at it with our telescopes. Its technical name is Rupus, or its accepted name is Rupus recta. It is not actually a cliff as much as it shows, but somewhere around a 45-degree angle. It's a slope, and it's fairly straight, but it's a simple thrust fault.
Okay.
And it's sometime, as you can see here, called the sword on the moon.
Right, you can see the saber.
Oh yeah, the handle and the guard.
Well, I don't suppose NASA's landed anywhere near there or plans to.
Mm-mm.
Yeah,
That'd be a
this is
great-
always a favorite at star parties when we get this phase.
Really?
Oh yeah, oh yeah.
And no plans to go there and land there. Okay.
You can see Albatenius too.
Someday you'll take a tour from the major cities on the moon and travel out into the wilderness, and you see the Rupus rectus.
It'll be a ski resort.
Yeah, that's right. This is a features that can sometimes be seen at the quarter moon. The lunar V, which is a play of light, and the lunar X, which is another play of light.
Mhm.
Not always visible, as Chuck points out.
Next for us, those will be visible April 16th from 8 p.m. to 10:34. And then after that, we won't see it again till June 13th from 7:18 to 9:48.
Okay.
So this is an actual photograph we're looking at.
Yeah.
Wow. X and a V.
Yeah, when you see it and it's there, it's obvious.
Mhm.
So,
Okay.
and
I was
then,
lucky enough to see them when Pat said, well, you can see the lunar X now. And I went there and sure enough, there it was, but it didn't
Yeah.
last very long.
Mhm.
Do we have any conspiracy theorists who say that face on Mars is somebody looking up at us?
don't
sure you do.
don't
There's-
start a new one.
You have crazies of all flavors.
When they got high resolution photographs of that, it's apparent it isn't a face.
Yeah.
I understand. Yeah, right. It sure looks like one at one point. Look at the golden handle. What is that? Half a
That-
crater?
That's this large bay.
Oh, it's not part of a crater.
It is.
It was
Yeah.
once a crater. The part
Yeah.
is buried down here.
What
but
it is.
it got overflowed with the lava created by something that was created this bigger crater.
I've never seen this one.
Hmm.
Yes, you have.
Is this sinus iridum or
The
anyway?
Bay of Rainbows.
Yeah, okay. Sinus iridum.
That's what I was going to ask, if it had a long name from the past instead of golden handle.
The golden handle.
Now, there's one of these two promontory points here. Under certain light, And with a small telescope, it looks like a woman's face with hair, long hair blowing away.
Hmm.
It's going upwards in this picture.
What's
Or
that?
like a 45 degree toward the 1 o'clock or 2 o'clock position.
Either this promontory or this one. I don't remember which it was. It was in a pamphlet from Edmund Scientific by someone Brown, Tom Brown or Tim Brown or something, that did a lot of what to look for and how to operate the equipment for Edmund Scientific back in the 50s.
But if that's supposed to be her hair, or then to me, the hair looks like it's blowing upwards toward about
Well,
1:30.
it doesn't necessarily, I'm not claiming that it looks like that in this picture, but under certain lighting conditions, it does strikingly look like a woman's face looking up with black hair going away from it.
Like a in profile, yeah.
Yeah.
Well, gentlemen, did I miss the name of the large C next to it, that Mare,
Mare Crisium.
that flatland?
No, that's not Mare Crisium. That might be Imbrium.
Imbrium, you're right.
Okay.
Crisium's on the other side of the picture, out of the picture.
Can I ask a stupid question real quick before we leave this about, I guess this might be maritime law. They're saying China may land on the South Pole and stake it for them. Is there a law involved in how much you can own of a land? I know this goes back to Columbus and colonizing the world, but
there's only laws that people are willing to respect in that sense. When we landed on the moon, we claimed it for all mankind. So that anyone, it's like Antarctica, where any country can send scientific teams there without interference.
But the flag we put on the moon was the American.
That's right.
And, you know, I was big of us.
But we did not claim it for America.
And also the landing sites, I think, you know, the immediate area becomes the sort of the property of whoever landed there, as far as you shouldn't go disturb it. Not necessarily that you own it, but that it shouldn't be disturbed.
Someday, though, it'll all be bulldozed and developed.
Yeah. And China's not exactly known for honoring maritime law, that's for sure.
Yeah.
They won't declare it for all mankind. But I wonder, like, could somebody stake that half of a crater we're looking at, the Golden Handle, and this is all India's or Japan's? Or
if they subscribe to the space exploration treaties that are out there, no, they can't.
Well, that's good to know.
One big word in what you just said, and that's the word if.
Yeah.
You don't have to.
Okay, let's largen the sky or enlarge the sky. There we go.
Yeah.
Pisces.
Now, this is the first point of Aries. We covered this a little bit last week. This is where the ecliptic and the equator cross, and it marks the transition to springtime. So that will happen tomorrow morning, March 19th at 8 p.m. Tomorrow evening at 8 p.m.
Yeah.
The Earth's equator outward is projected onto the celestial sphere there, and the sun's path through the ecliptic, this one, cross at the first point of Aries. Now, this was defined a long time ago, 1,000 years or so, and you can see that the first point of Aries now occurs in Pisces. Aries is way back here.
Those two little hooks don't denote Taurus's bullhorns, or
no,
am I?
No.
That's
Aries
a ram. That's a ram.
It's a ram. Oh, okay, got it.
In ancient astronomy, and I mean back to the 500 or more years ago, they had symbols for the major events or things and places and planets and stuff. So each one has a characteristic symbol. And this is the one for Aries, the first point of Aries. There's one for each of the planets, and I think a few other points in the sky.
Yeah, but because they considered the first several asteroids to be planets, they all get little symbols too.
Okay. But that stuff is no longer used except in astrology.
Yeah.
Well,
They've gone to Greek letters, right?
Then what?
They've gone to Greek letters.
I think this was more symbols for when people were illiterate.
There's never a possibility Ophiuchus will come into the zodiac.
It is in the zodiac.
It is. Well, Most people
not-
don't know about it.
Oh, some people have their own mythologies. They just go their own way. So we have had a summer triangle and a winter triangle. And now Astronomy Magazine is pointing out the spring triangle, Arcturus, Denebola, and Spica.
I think they would have used Regulus since it's brighter.
Gotta tell you, gentlemen, any three stars up there, and you see thousands will make a triangle. How in the world would they take one and define it?
You can do that if you want to make your own asterism and, talk it, tell everybody about it at an outreach or something.
Well,
Yeah,
name it
you're right.
wrong.
You're right, Chuck. Denebola is not as bright as Regulus.
You're
Yeah.
right.
Wow.
But it does make a roughly equilateral triangle.
Yeah, that's the point.
But why is it the spring triangle? Why
Because
is it?
it's up in the spring right now.
Oh, we don't always see it?
That's correct.
No.
Okay.
6 months from now, you won't see it at the same time of day or night.
In a couple of months, we'll be using the summer triangle,
Right.
Ron.
So we have a triangle every season and we only see it during that season.
Well, you see the summer triangle well into winter.
Yeah.
Yeah, it just depends on what time you consider convenient for viewing it. But there's probably only, a month or two that you don't see it because it's in the daytime near the bright sun.
For example, we have the summer constellations, where we look at the core of our galaxy,
Right.
Sagittarius, and that's up in the convenience of a warm evening. So that's associated with the summer. But that same constellation is up and being very bright right now, but you have to get up early in the morning. So that's why we don't consider it a spring triangle or in the morning.
But there's a bunch of triangles and constellations that Australia sees that we'll never see, right?
So with this many dots in the sky, there's a zillion ways you can hook them up.
Right, but we don't see all the things that people in the southern hemisphere can see, and
Yeah,
vice
that's
versa.
true.
That's my
Anything
point.
with it, we're at 34.5 degrees north latitude, and anything within 34.5 degrees of the South Pole projection into the sky, we do not see. Does not come above our horizon.
Ever.
So this common sky that we see pictured, you'll never see the one above Antarctica. Well, that could be a whole new world, if that's the word I can use, of different,
Yeah, for
red giants.
For example, the large and small Magellanic Clouds, the two small dwarf galaxies that orbit our galaxy, we'll never see those in the United States.
Wow.
Well, if you take precession into account, we might someday.
Well, I mean, within our lifetime.
Yeah. And actually, that would be really severe precession. But Ron, think of this. If you were at the North Pole, okay, the stars just make circles around your horizon. So you always see the same set of stars. You don't have a seasonal set, okay? But here, because we have this 34.5 degrees of north latitude, we see some sort of come and go.
Yeah.
Okay, well, answer me this. If there were no tilt to the Earth, if we didn't have the seasons and there wasn't that 23 or 27 degrees, I forget which it is.
23.
Straight up and down, there would be no seasons. And the people at in the Arctic Circle, which gets 24 hours of daylight during the summer and 24 hours, they'd get the same 12-hour dark, 12-hour black, or 12 hours light as they do on the equator.
Right. It would be much more evenly distributed.
Right.
The sun would just go around there at the equator, right?
Yeah.
So right here in this picture, in this diagram, you can see this is Ursa Major, the big bear. And this is M51, the double whirlpool galaxy. And that stuff is pretty much visible all year long from northern hemisphere here. So it just rotates around Polaris.
When I was up in the Arctic tent cap, we were near on Ice Island T3, 300 miles from the North Pole. It was springtime, and the sun was always up. And the mess hall served 4 meals a day because I found myself on a 30-hour day.
Wow.
I'd sleep 10 hours and be up for 20 because it didn't matter. The sun was always up.
Well, yeah, during the summer. That's like the
It's springtime.
Arctic and
springtime.
Antarctic. I just wonder what it would be like on the North Pole if we had no tilt. What would you, it would always be day or always be night?
No, it wouldn't. It would be like you said for the South Pole. You'd have 12 and 12.
Well, you'd be seeing the sun out on the horizon always there.
No,
Yeah,
you
it would
can't
just
see
go
the
around.
equator from the North Pole. It's right around your horizon.
Yeah.
It would be twilight.
Yeah.
Be constant twilight. All right.
Yeah.
Fascinating.
So a friend of mine that I worked with at Santa Barbara Research Center, one time we took a trip to the East Coast, leaving on Sunday. We got there with ill-prepared view graphs. So we spent all night in a Kinko's or whatever they have back there that counts for that. We went to our 8 o'clock meeting, and then we went to a series of meetings into that evening, and then we got back on a plane and came back. And John reported that he didn't, before this trip, he didn't know it was possible to work 27 hours in one day.
I don't know. That's why there's such a suicide rate in that dark time of the North.
Don't tell Elon Musk that, or he'll try to have his workers go traveling like that while
Yeah,
they're
right.
Right.
So in the
Okay.
springtime, we have a constellation of
Cancer.
Cancer.
As in
And
Tropic of.
we have a springtime Messier object called the Beehive Cluster, which is a very large cluster right at the center of Cancer, M44, or the Beehive Cluster. And it's a very big thing. It's hard to look at through a telescope. You need wide field binoculars or a real dark sight and your naked eye. And the reason it's called the Beehive Cluster is because back in medieval times, the beehives were traditionally shaped like this. These are woven structures or clay structures that were made for the bees, and that was where bees were commonly kept. And so the beehive cluster here, you can see that it has this smooth conical beehive shape. And then these other bright stars are the bees going around it.
Yeah.
And
I
it's
was
really
always
colorful.
struck with all the triangles you could see in this cluster.
Yeah.
Funny triangles.
Yeah, you can visually you can see a lot more triangles than this photograph shows.
Well,
And the ancient Greeks used this to predict the weather. If you could see the fuzzy little glow in Cancer, there probably wasn't going to rain the next day.
Yeah.
so
This cluster is also known as Precipice the Manger, the Christ child. And so you'll see on Jerry's first picture, Ocellus borealis and Ocellus australis.
There.
Yeah. So Ocellus in Latin means an ass or a donkey. So these were the donkeys at the manger. And the one up above is the one in the north, and the one down below is the one in the south.
They don't show up in this picture, though, do they?
No, they're out of the frame.
Yeah.
They're out of frame, yeah.
But that's not what the 3 wise men saw coming upon Bethlehem, right? That's something else.
No, they were firefighters, Ron.
Who was firefighters?
The 3 wise men were firefighters. You know that, don't you?
No, tell me that story, Tom.
Well, the Bible says they came from afar.
Oh.
But
Thanks, Bruce.
That's like
Okay.
what do you call a deer with no eyes? No idea.
no idea. Jerry, when did we lose control? Do you know exactly what point?
I'm not sure we ever had it.
I don't think so. You're right. So bees.
Yeah.
I love it. All right, we're back to the local comets in the sky, the big one.
Yeah.
And one of the worst star maps ever.
Right.
You hate these. You hate these, don't you?
And I didn't feel like redrawing it. So
Yeah.
you can see that between March 1 and March 5, it travels this distance. That's 5 days. But during these 5 days, you see it's covering a greater distance. So it's obviously speeding up in our sky. It's heading towards its closest approach to the sun. This is the Andromeda Galaxy. and NGC 404. But this is the comet as it travels from Pegasus into Pisces. M33 is down here. And over the weekend, the last 4 or 5 days, there have been an increasing number of pictures and diagrams of this effect. One here shows how close everything is to the horizon.
Yeah.
In the evening, this is the west, and this is the sun below the horizon. Still twilight. The comet is up here. I don't know why they did this coloration of it.
I think they're showing the brightness change, but it shouldn't be getting dimmer.
No, and it's apparently 5th magnitude right about now.
Wow.
Oh, that's pretty good.
Yeah. Still needs a dark sky. This is a picture that was taken. Let's see if I have a.
It's like 5 days ago.
Yeah. So these have all been taken within the last 4 or 5 days. It's quite a nice picture. It's a challenging. This was taken farther. The comet has traveled farther from the previous picture.
From Andromeda up there?
What's that?
Is that Andromeda at the top?
Yeah.
Yeah, this is Andromeda Galaxy, and it has two
110.
32, 110.
dwarf galaxies.
And 110.
To the right.
Right.
Well, now, is it going to be seen by us because it's closer to the sun or because it's just closer to us? It's brightness.
Closer to the sun drives the brightness.
Yeah.
Does it
In
really?
this case, yeah.
And it only has one tail that we can see. Some of them
It's
have.
an ion tail, yeah. Well, no, there's more. There's a lot of structure to it. You'll see in a moment, because it turns out that the comet is today's APOD, astronomy picture of the day, which I have here. This is a picture taken from Spain of the comet. Shows how close to the horizon it is. This is not the sun. This guy's holding a flashlight. If that were the sun, you wouldn't see any of this. This is the picture of the day today, and it shows a lot of structure. I could not find a citation that tells me what instrument it was taken through. But
this was on the space weather site a couple of days ago.
Okay.
And the photographer, I can't remember his name, but he applied a filter, to show these gradients in the the structure in the.
Yeah, it's called a rotational symmetry. I forget the name of it too, but it's a certain type of filter in processing. And we showed the thing very briefly last week, what it can do. And this guy did it, and it's just a beautiful shot.
Yeah.
And you can see different tails streaming off here. The blue ion trail going here, the green up here, and you can see some red structure in this, what's spiraling out of the nucleus. So I'd say the nucleus is rotating there.
Yeah.
But does science say that all comets by definition come from outside of the 9 planets orbits? In other words,
No.
Originating Kuiper. Did we get some out of the asteroid belt between Mars and Jupiter?
Well, yeah, there are some active asteroids, they call them, when they do that.
Okay.
But their original source, at least for most comets these days, is far out there. But some of them have been captured. Like Halley's doesn't go out any farther than between Uranus and Neptune.
Really? So it's almost like a mini planet or an asteroid.
Yeah, it's a minor body.
Yeah, it's our pet comet.
Yeah.
Does it become a comet when it has water? The others are dry, and so they don't give us a tail. They don't spurt.
Well,
right?
it's when it has a tail. It's not necessarily from water, but it could be carbon dioxide or diatomic carbon, all kinds of stuff.
Any volatile gas, anything that's frozen solid, and then when it gets near the heat of the sun, it evaporates and shows a tail.
But we pretty much know where all of the comets we watch originated, where they're going back to.
Not necessarily.
Really?
Oh, well, once you got an orbit, you know something about them. Yeah.
Yeah,
we
famous periodic comets we know about.
Yeah.
So we don't know where Pons Brooks came from.
Sure.
I don't know. I don't know, but I don't know if someone else knows.
Do you suppose
It's not a interstellar comet.
Well, I know that.
It's got a short period, Ron, so it's a close in orbiter.
Yeah.
Okay. Are there any long ones that come from the Oort cloud?
Yes.
Really? We get comets from clear out there.
Yeah.
Yeah, we had one a while ago that had a period of about 50,000 years, as I recall.
Mhm.
That's
Lord.
how they first speculated that the Oort cloud existed, was because you would see these high inclination comets that are coming from, perpendicular to the plane of the solar system.
But then we're talking hundreds or thousands of years orbit time.
Yeah.
Whereas your Halley's is what, 70 or 80 years, and therefore
76.
it must be from within the solar system, or certainly the Kuiper belt would be as far out as it would be from, right?
Well, no, not necessarily, because it interacted with Jupiter at some point and got captured.
Ah, well, it's difficult to imagine a comet that comes down and goes around the sun and then goes back into what we call the asteroid belt. Seems to me it wouldn't be in the asteroid belt ever. It's always on its own elliptical.
Well, the ellipse can be any size you want.
Well,
The
but
sun is at one of the foci of the ellipse.
the asteroid belt is not ellipticals. They're all going like the planets, aren't they? All those rocks. Well,
Yeah,
well,
individuals.
they're
Individual things
elliptical.
are in.
You don't know that for sure. An individual body in the asteroid belt doesn't necessarily go in a circular orbit.
Yeah.
It could be elliptical.
Yeah. But if it is elliptical, if something's in an elliptical orbit, it spends almost all of its time far away from the center. And when it does get near the sun, it whips around it real fast and heads back out.
If it's a very, very elliptical orbit.
Yeah,
Yeah.
yeah.
but most rocks in space are dry, or do they have all these gases and frozen?
They will eventually become dry.
If they
dry
come in
out?
close to the sun.
Right.
But there are these active asteroids where there's volatiles inside, shielded from the sun, and they collide with each other, or something happens, a little landslide, and it exposes that, and then you have a tail coming off the object. So
there's
it's fuzzy, Ron. It's fuzzy, just like most things.
I know, but we can't see the dry ones that are going around the sun, just like a comet, if they don't have anything to push gas out and make tails, right?
We don't see their tail because they don't have one. Yeah.
Okay.
If the asteroid Ceres were to move in close to the sun, change its orbit, it would be one hell of a comet because it's mostly made out of water.
And the comet / asteroid that's the source of the Geminid shower in December is basically mostly devoid of volatiles now. So it's more like an asteroidal source of a meteor shower.
And Ceres is a dwarf planet. Heck,
Yeah.
that would really be something. Okay, here we go. The lovers are coming together in space. Venus and Saturn.
This is Venus and Saturn at a close approach in 2016. It hasn't happened yet, so we don't have a picture of it this week.
Wow.
But Astronomy Magazine, with one of their charts, shows on the horizon, March 21, Thursday, I think that is, 30 minutes before sunrise, and you see them as close together as they're going to get. And this is
just to show you how Venus has been moving with respect to the planets here. A couple of weeks ago, it was really close to Mars.
Has there ever been
Mars
have you
is
ever
right
seen
here.
Gentlemen, has there ever been an occultation of those planets?
Yes.
Really? They pass one another and obliterate?
Yeah.
Okay, I would think that would be a rare event.
Of course, they're not
very
close
rare.
to each other spatially, just angularly.
Yeah. But it's very rare.
Yeah. So this is the planetarium software. It shows the sun up here. And one feature of the planetarium software is you can get dark skies on command. And so here you have Venus and Saturn at their time of closest approach, which is 8 p.m. on March 21st.
Okay.
And then down here, as pointed out by Tom, you can see Mars, where Venus was a short while ago.
Yeah.
But at 8 p.m., you won't be seeing this.
That's right. Yeah. I saw Venus this morning easily with naked eye around about 7 in the morning.
Yeah, it's pre-dawn objects.
Yes.
Well, you know those sky chart diagrams that you hate to see earlier.
Yeah.
That reminds me
No,
of how,
the lack of features, just a lot of dots around.
well, I was going to say it reminds me of how the old sky shows inside the planetarium used to look. There was a lot of grid up there and little fake dots and whatnot. Okay, where are we now, Mr. President?
We are, whoops, looking at Mercury. This is the best time to see Mercury.
Mhm.
Let me
It
get
was easy
Yeah.
Friday and Saturday nights.
Yeah. And last night here it was easy. It's really nice.
yeah, this is Jupiter up here,
Mhm.
and Mercury is here, and the sun is down here.
Mhm.
And of course, Van Manen star,
Mhm.
which I saw for the first time on this chart. Anyway,
That's
This
a
is about
fast mover, Van Manen.
is it?
It really scorches through the sky. Yeah.
So there's another one, Bernard star.
Yes.
That's a
Barnard
very
Star,
fast.
yes. Mhm.
Barnard
But-
store, from one year to the next, you take photos and you can see it move relative to
Yeah.
the background.
Yeah.
Yeah.
So this is as far as Mercury's going to get from the sun in our sky angularly. So this is a good time to see it.
Yep.
This will be in the morning sky.
No, evening
No,
sky.
no, this is
that
evening
right?
now, Jerry.
That's what
Oh
elongation.
yeah, high in the west. Yeah, you're right.
Yes.
Evening sky. Yeah, with Uranus and Jupiter.
And I think in a couple of months, Jerry, Mercury and Venus will be close to one another. And
Okay.
yeah, I believe it'll be in the evening sky, if I remember right. Chuck, what do you think?
Well, that's where Venus will be, so it has to be.
Yeah, yeah.
Well, if we're looking through the telescope and see it at this point, this is conjunction, or no, this is elongation. It
Mhm.
looks like it'll look like a small version of our quarter moon. the half of
More
Okay,
like a
yeah.
gibbous. More like gibbous.
Yeah.
Yeah.
Oh, gibbous moon. Okay.
Mhm.
Wow.
But it's
It's
pretty,
really
you
bright.
know,
It's really bright, Ron. It's about magnitude -1 roughly,
yeah, you'll see it with your naked eye. But
easily.
through the scope, I mean, it's low in the sky, even though
Mhm.
it's at its highest. And the skies have been wiggly. So it was pretty flappy when we were looking at it.
Mhm, mhm.
Yeah.
Yeah, I showed it to people at Westmont on the Saturday gig.
Yeah.
Just, it's easy to see.
You were talking about the beehive cluster. There was one of the principals that was there on Saturday keeps bees, and she wanted to see it.
Uh-huh.
And it shows up very nicely in my finder scope, which is only 25 power magnification.
Oh, that's a good idea.
Sure.
Yeah.
Mhm.
Not just a fuzz ball. You can actually see all those little stars distinctly apart, huh?
You know, it's
Yeah.
too big. My main scope, the power is too high. You
Yeah.
don't see the whole
Yeah.
thing.
Yeah.
You need a
Look.
super wide field of view to see the beehive.
Yeah, it's one of the two really pretty open clusters in Cancer the Crab. The other one's 67, which is older stars, I think.
So we're now looking at cliffside property following the storms in California, right?
This is Isla Vista transferred to Mars.
Right.
This shows the Mars Surveyor, I think that's called NASA's InSight lander, which is as a seismometer. This thing here, and when things hit Mars, wherever they hit, it bounces waves through the core, and this seismometer records them and sends the information home.
Ah, that's a good idea.
Yeah. So
it's got a bigger ball in the middle. Big.
Well, the thing is that they're trying to hone in on, they had a picture of Mars that was odd. Like, it's hard to do it with blurry data, and I think this is the equivalent of that. But you see, like in Betelgeuse, we have a better model now. The earlier Mars image from seismometry showed it had a large light core rich in low density elements. But now it has more of they've decided that it has more of an Earth-like high density core, an iron core, liquid iron core. So
liquid iron. Wow.
It's still molten.
And the blue line here is from their seismometry from Mars quakes caused by its crust shifting as it shrinks, as it cools. And that's bounced off the top of the this liquid layer. And so they thought the core was that big. But then they got a meteorite impact where the I don't know, purplish or darker line is. And that came through, and from its path, they could extrapolate that there was this extra little molten layer here that was fooling them, making them think that the core was much bigger.
Right. So this is the impact or the event site, the source of seismic activity. This is the InSight lander over here. And so what Chuck just described is the path of this seismic wave going through and detecting this layer. Whereas earlier they thought that this was the core, but it's not. This is the core.
So the bright yellow layer that you're showing there is not iron.
Right. That's the molten rock.
Yeah. Yeah, molten rock, excuse me. Yeah.
Okay, and iron underneath that gives Mars a nice heavy-duty magnetic field?
No.
No. Really?
Mars does not have a magnetic field to speak of. It has a very weak one, and that's going to be a major problem for colonization of Mars.
Why?
So the orange area that's above that bright yellow ring isn't liquid enough to support cells of motion cells. The thing that creates the magnetic field on Earth.
Yeah.
In other words, the core's got to be moving, right, to create a magnetic field. There's got to be big.
It's not entirely pinned down what produces magnetic fields in the core, like of the Earth and Mars and stuff. There's a guy that has a large, several tons of rotating liquid sodium that he's trying to generate planet scale, or rather model how core convection can produce a magnetic field that we see in the planets. And so far, no definitive results that I've seen.
You need some kind of dynamo.
Yeah, some kind of dynamo effect.
Well, I thought that's the reason our North Pole moves around, is because the dynamo that's creating it moves around.
Yeah, it does. I think you're right. There are convection cells on Earth, and the plates up here on the Earth, the actual crust is in proportion to the plastic or liquid. Not necessarily, well, it is hot, but the crust to the core, to the innards, is roughly the same ratio as in an egg, of the eggshell to the liquid part of the egg. So we are really a molten planet with a very thin crust that moves around on the convection cells. We have plate tectonics. As Bruce points out, we don't have a lot of understanding of plate tectonics here, but for whatever reason, Mars does not have a significant magnetic field. And either we're going to have to do everything underground, or we're going to have to generate a magnetic field.
But that orange we're looking at is not magma, right? It's pretty solid above that.
It's really viscous.
Yeah. It's what I call plastic. It's compressed so much that it moves viscously. Yeah. It's like silly putty.
Okay. And Mars quakes are not caused by floating continents and tectonic.
Bashing into each other.
Yeah. It's shrinking, as Chuck said, somehow.
Yeah, as Mars cools off, the crust it shrinks, and the crust is rigid, and then it cracks as it
and occasionally it gets those dreaded rocks that we keep hoping don't hit us. They'll hit Mars, right?
Yeah.
Okay.
Well, sometimes it hit Mars and knocks off rocks that end up crashing onto Earth. Meteorites.
That's where we get Martian meteorites.
Yeah.
Well, I just read something strange about Deimos and Phobos, the two moons, and I forget, it was totally different from what they thought before. They're not captured asteroids, are they?
Right. They think they're debris from a collision with a cometary-like body.
Huh.
Whoa. Future stuff to talk about, Mr. President, as we reach the end of our incredible 161st hour of the Astro Hour for March 18th to the 24th. Let me quickly run over a couple of things. We've switched dates of our first Friday to the second Friday of April. It'll be our general meeting inside what's called the Courtyard Gallery. It looks pretty nice in the pictures you've been sent. all those incredible photos of the universe on the wall. And I guess we're inside, we'll be warm. They're going to set up chairs on the 12th of April for our speaker from Citrus College, who is Dr. Dave Carey, talking about on the subject, the rush, I think it's the word rush, the something to find intelligent life in the universe, since there's very little here on this planet. And then they're going to move Star Party up to the first weekend, which will be the 6th of April. And we're meeting
okay.
a week later. Okay, got it. But in between, the 8th of April is the partial eclipse, which is exactly 3 weeks from the day. That's the 8th. And we're going to convene, the club is anyway, out at Camino Real Marketplace, right?
Right.
Yep.
Mhm.
And they'll distribute the glasses. You can do your pinhole stuff. You'll be with us. What are we going to do? Have we decided, can I just stay here at home, or shall I go out there and bring my laptop? Hope to hook into Wi-Fi, or what's our meeting going to be like?
We'll be the eclipse will be from roughly 10 a.m. till a little afternoon. So
Yeah.
that's when we'll be doing the observing, just to let
Right.
people know.
And
Well, I'm
I will
talking
be
about-
there too. I'll be there too, Chuck.
Yeah.
So you're
Right
not
in front of Anna's Bakery.
okay. So how are we going to do the April 8th Astro Hour, the program we're on right now? Are we moving it, or are we going to still do it?
I think we will be taking a vacation, a brief
Yeah.
vacation.
It might be our one missed session.
Yeah.
Okay, well, come up with a decision, since this will be when's our planning meeting for April? Does anybody know? Is that the first
Before the
weekend?
Star Party.
So it'll be during the first weekend, the 6th
Yeah.
April. Okay, gentlemen,
Mhm.
take care of yourselves, take care of your wives and wonder, and doggone, it's number 161. We'll see you back here on March 25th, a week from today.
Thank you.
For the
Thank you, guys.
Astro Hour. You did good.
Thanks, everybody.